Bless you. Okay, so the second problem on our bell work was an OR problem, but it was two things. They were going separate directions. They didn't intersect, correct? So OR is just the union of those two sets. We just put them together on the same number line. So let's take a look at ORs that might be a little bit different. So I'm going to graph this. Okay, so on this number line, how do I show x is less than a negative 5? Tyrese, x is less than a negative 5. How do I show that on my number line? Open to the left, yep. Okay, so I've got an open circle and I'm going to the left. How would I show, Jarrett, x is less than 1? Open circle going to the left. Okay, so OR means putting them both together. We don't want to leave the graph like this. Okay, so we have to make a brand new graph that shows both of them put together. And are they both in this range up here? No. Are they both, or no, the question I should ask, do we have at least one of our solutions in this range? In the range above 1? Nope. Do we have at least one in the range from 1 to negative 5? Yeah? Do we have at least one in the range from negative 5 on left? Yeah. Actually, we have both of them in that range. So our answer or our solution has to show both of them put together, whether they overlap or not. So where does our solution start when we move right to left? Where does it start? At least one of them starts at 1. So our final graph is going to be where we show both of those put together. And it would start at 1. So our final solution is all of the values less than 1. So we would write x less than 1 as our final inequality, and that would be the graph. Okay, another special OR. Trenton, greater than negative 2, which I didn't put on there yet. There we go. Greater than negative 2, how would we show that? Open or closed circle at negative 2. Does it show equal sign as well? No, so it's open. And then greater than, is that to the left or to the right? To the right. Okay. Kimberly, greater than 0. What do we have at 0? Open or closed circle? And then greater than would be which direction? To the right. Okay, so since they're both going to the right, what's our farthest left point there where there is a solution? Farthest left point would be at negative 2. So our final graph to show both of those put together would be from negative 2 to infinity. And then we would want to rewrite our answer as not just x greater than negative 2 or x greater than 0. We're just going to say x greater than negative 2. Yes. Well, see how, that's a great question. See how this graph goes over the 0 and picks that up. So when it's or, it could be one or the other. It doesn't have to be from both. Like and has to be from both. What they have in common. Both of them have to have that as a solution. Or only one. At least one has to. So this, starting at -2, going all the way to the right, it picks up that 0. It picks up all of these solutions, doesn't it? Picks up the 0, greater than 0 solutions. So I guess the simplest way to show this answer would be to show one graph that starts at -2. This is messy up here where we have the two graphs. So we can rewrite this simpler, just like when we simplify equations. We could simplify our graph to just show everything from -2 and to the right. And then our inequality would be simpler written as 1. Okay, any other questions? So it picks up that 0. Let's do one more like this. Okay, so how do I show x greater than -1? Open or close circle? Open at -1, and greater than would be right. Okay, oh, I know why you're asking that. Okay, less than 3, how do we show that? To the left. Okay, so this is especially special inequality. And so we have stuff greater than and stuff less than. What's our farthest left point that we have something covered? Where do we start on the left? Is there an ending point on the left, I guess is my question. No, because it keeps going out forever. So, okay, so is there an ending point on the right? Nope. Is everything in the middle covered? Is this 3 covered by this one? Yep. Is the 1 covered by that one? It is. It looks like the whole number line is covered by this. And it is. Because remember, or means you just put them both together and that's the solution. So we're going to do this. This is the whole number line, which is another way of saying all real numbers. Have you ever heard that before? Well, hopefully you have. If you haven't, you're going to hear it now. So the solution to this inequality, this compound inequality, is going to be any number on our number line. So to show that, we would just draw a number line, and then above it, we're going to draw this. There's our solution. Any number on the number line, and then would be part of the solution. And then we're just going to write a big capital R, which means all real numbers are a solution to this inequality. Bless you. Okay. Any other questions on this one? One more, and then we're good to go. Here we go. Let's move on to this one. This is going to be a special and one. So what letter are we on? C or D? D. So we have x is greater than 5 and x is less than 0. Less than or equal to 0. Let's do that. You got these down, Evan? You writing these down? Tawny, greater than 5. How do I draw that? Open at 5, going to the right. Let's just go with less than or equal to 0. What do we got there, Tawny? To the left. Okay. And means the intersection, where they intersect. Do these graphs ever intersect? No. So that means there's no solution. Our answer would be no solution. That's, or empty set is how we would say that. There's no set of numbers that will work for both of these. It has to work for both. On the, okay, we'll just call it that. We'll leave it at that for today. Okay. All right, so your assignment today is a fun worksheet.